Welcome to Frost and Sullivan's Growth Podcast. In each episode, we take a deeper look at transformative shifts shaping global ecosystems, from industry megatrends and technology innovation to evolving customer expectations. Today, we're exploring growth opportunities and transformation in enterprise network services, unpacking where the next wave of opportunity is unfolding and what it means for future-ready businesses.
Most enterprise networks today don't fail because they're too slow. They fail because organizations can't actually see what's happening inside them. Think about it. A company might have world-class cloud infrastructure, expensive cybersecurity tools, high-speed connectivity, and advanced monitoring dashboards, and still struggle to identify why applications slow down, why threats move undetected, or why outages spiral into business disruptions. Why? Because modern enterprise environments have become incredibly fragmented. Data flows across clouds. Employees work remotely. Applications live everywhere. AI systems generate massive workloads. And security policies stretch across dozens of disconnected platforms. The result is something many IT leaders quietly admit behind closed doors: too much complexity, not enough visibility. But now, something fundamental is changing. Artificial intelligence is starting to turn networks into intelligent systems capable of observing, analyzing, predicting, and even acting in real time. And once networks become intelligent, they stop being passive infrastructure, because the future of networking isn't just about connecting people and systems anymore. It's about enabling intelligent business decisions at scale. So here's the question that frames this entire conversation. What happens when networks stop being pipes and start becoming brains?
For decades, enterprise networks had one primary job: move data from point A to point B. That was it. Success meant uptime, bandwidth, and speed. But modern enterprise environments have completely changed the equation. Today, networks sit in the middle of nearly every critical business operation: cloud computing, AI workloads, customer applications, supply chains, remote collaboration, real-time analytics. And suddenly, simply moving traffic isn't enough anymore. Organizations now need networks that understand context. For example, is this traffic normal? Is this user behavior suspicious? Will this workload create congestion later today? Is this application violating compliance rules? Could this spike indicate a ransomware attack? Traditional networks couldn't answer those questions, but AI-driven observability can. This is one of the biggest shifts happening in enterprise infrastructure right now. Observability platforms powered by AI are helping organizations correlate data across cloud environments, applications, security systems, endpoints, and network infrastructure simultaneously. Imagine an enterprise network detecting abnormal behavior inside a multi-cloud environment, automatically isolating suspicious traffic, rerouting workloads, and alerting security teams, all before employees notice disruption. That's not science fiction anymore. It's increasingly becoming operational reality. That means networking teams are no longer just supporting business operations. They're actively shaping business resilience, security, and growth. If your network could suddenly tell you everything happening across your business in real time, would your organization even know how to use that intelligence effectively?
Now let's talk about something that sounds futuristic, but is already happening quietly inside advanced enterprise environments: self-operating networks. This is where agentic AI enters the picture. Traditional automation works like a checklist. If something breaks, execute a predefined response. But agentic AI is different. It analyzes conditions, adapts dynamically, learns from behavior, and makes operational decisions with minimal human involvement. That's a massive leap forward, because managing enterprise networks manually has become nearly impossible at scale. Think about the sheer complexity organizations face today: thousands of endpoints, distributed cloud applications, AI workloads consuming enormous bandwidth, remote users across geographies, continuous security monitoring. Human teams simply can't react fast enough to every operational issue. So networks are beginning to automate themselves. We're already seeing AI-driven traffic engineering, predictive capacity planning, closed-loop fault remediation, real-time workload optimization. In practical terms, that means networks can increasingly detect problems, diagnose them, and fix them automatically. And that matters because AI workloads are changing infrastructure economics dramatically. Generative AI systems require huge amounts of GPU compute power, but building internal GPU infrastructure is expensive, difficult to scale, and operationally complex. That's why GPU as a service is gaining momentum. Instead of buying massive GPU clusters, enterprises consume AI compute resources on demand. But this creates a new dependency. The network becomes the backbone connecting distributed AI infrastructure. If connectivity fails, AI performance suffers. If latency spikes, applications slow down. If bandwidth fluctuates, productivity drops. So networking providers are no longer just delivering connectivity. They're becoming orchestrators of intelligent compute ecosystems. And that's changing business models too. Consumption-based infrastructure, network-as-a-service platforms, integrated observability, dynamic scaling. The network is becoming a service platform instead of static infrastructure. But there's also a deeper human question here. As networks become increasingly autonomous, how much operational decision-making are organizations truly comfortable handing over to AI?
Earlier cybersecurity strategy was built around a simple idea: protect the perimeter, build strong walls, keep attackers outside, secure the edge. But modern enterprise architecture destroyed the perimeter. Today, users work from everywhere. Applications run across multiple clouds. AI systems exchange data continuously. Devices connect from thousands of locations simultaneously, and attackers know it. Modern cyber threats are faster, more automated, and increasingly AI-driven themselves. Some attacks now move laterally across enterprise environments in minutes. That means traditional security models are no longer fast enough. Security can't sit outside the network anymore. It has to become part of the network itself. This is why embedded security is becoming one of the most important shifts in enterprise networking. Technologies like Zero Trust Architecture, SACE, Secure Access Service Edge, AI-driven threat analytics, real-time policy enforcement are integrating security directly into connectivity infrastructure. Instead of verifying users once, networks now continuously validate identity, behavior, devices, and workload activity in real time. Every connection becomes contextual. And there's another layer making this even more complicated: regulation. Data sovereignty laws are expanding globally. Countries increasingly want localized control over sensitive data. Compliance requirements vary dramatically across regions. That means enterprise networks now need to understand geography, jurisdiction, encryption standards, and policy requirements simultaneously. In other words, future-ready networks won't just move data securely. They'll need to understand where data is allowed to move and why. So here's the critical question. If cybersecurity threats are evolving faster than human teams can respond, should intelligent networks become the first line of defense?
So what does the future-ready enterprise network actually look like? Not just technically, but operationally? The answer is surprisingly clear. The next generation of enterprise networks will be adaptive, observable, autonomous, secure by design, and deeply aligned with business outcomes. Let's look at what that means in practice. First, security becomes operationally embedded, not bolted on later. Zero trust access, AI-driven threat detection, and real-time policy enforcement become native network capabilities across SD-WAN, branch infrastructure, and multi-cloud environments. Second, enterprises align infrastructure investments with GPUs demand. AI workloads fluctuate constantly. Static infrastructure often becomes inefficient. Flexible, consumption-based compute models allow organizations to scale AI operations without massive upfront investment, but only if the network can dynamically support those changing workloads. Third, edge computing becomes essential for private AI systems. Running large language models closer to where data is generated reduces latency, improves responsiveness, and minimizes bandwidth bottlenecks. This becomes especially valuable in smart manufacturing, autonomous systems, computer vision, healthcare diagnostics, smart city infrastructure. Fourth, sovereign-ready connectivity becomes mandatory. Geofenced routing, jurisdiction-aware traffic management, localized compliance controls. These capabilities are rapidly becoming table stakes for global enterprises. And finally, organizations begin integrating quantum-safe capabilities gradually rather than waiting for complete infrastructure overhauls. But perhaps the most important lesson is this: technology investments alone won't determine success. Execution will. The companies that succeed won't necessarily be the ones spending the most money. they'll be the ones operationalizing intelligence most effectively. Because modern networks are no longer passive infrastructure systems, they're becoming living digital ecosystems. So here's the final question before we close. Is your organization building networks designed simply to support operations, or networks designed to accelerate transformation itself?
The convergence of AI, security, observability, automation, and connectivity is reshaping enterprise architecture from the inside out. And the organizations recognizing this shift early are positioning themselves for a very different future. Because the next generation of enterprise leaders won't just ask, how fast is our network? They'll ask, how intelligent is it? And maybe that's the defining idea behind everything we discussed today.
That's all for today. Thanks for joining us on Frost & Sullivan's Growth Podcast. For access to our research, competitive benchmarking, and best practice frameworks, head over to frost.com or email hello@frost.com. We'll be back soon with more to help you stay clear-headed and growth-ready.